Now, if we're going to be studying chemical reactions, we want to make sure that we're following the laws of physics. And so I want to duck back for a moment to Dalton's atomic theory and remind us of some key features that we've got to make sure we follow whenever we're doing a reaction. Now, one of his postulates was that all matter is comprised of atoms. Now, we know that there's smaller things than the atom, but they don't have any unique characteristics anymore. Now we're just talking about electrons and protons and neutrons. Oxygen no longer acts like an oxygen atom when it gets broken down further than that. So we have to make sure that all of our atoms remain the same. Atoms of one type can't be converted into other elements in a chemical reaction. As I pointed out, that means we're going to have to make sure that our atoms are the same before and after. If we have a nuclear reaction, we will see elements change, but we're not going to focus on that in Chem 1. Now, all atoms of an element have the same number of protons and electrons, then they're going to be the same element. Oxygen will always have the same number of protons and electrons. Hydrogen will always have one proton and one electron. Now, hydrogen and deuterium both have one proton and one electron. They will behave the same way for our reactions because they're both isotopes of hydrogen. By adding one extra neutron to go from hydrogen to deuterium, we do have a different isotope, but because the characteristics are all based on the interaction of the proton and the electron, from that we're going to be able to say these interactions are going to be the same. The chemistry from hydrogen versus deuterium should be pretty much the same. And there'll be some small deviations that happen with higher level chemistry that we'll study later on, but when we're talking about reactions, it's true. Hydrogen, deuterium, uranium-235 and uranium-238, all of these sets of isotopes are going to react the same way as any other member of their isotopic family. Now, that doesn't mean hydrogen and uranium act the same way. It means that hydrogen and deuterium act the same way. And compounds are going to be formed by the chemical combination of two or more elements, keyword, in specific ratios. So we're going to be communicating those ratios with the subscripts on our atoms and our molecules. Now, all of this should remind us that when we have a reaction, we must have the exact same set of atoms at the beginning and end of a reaction. If I start out with 10 carbons, all 10 carbons must be present in the final products. Not 11, not 9, not 1, not 50. If I start with 10 carbons, there must be 10 carbons in the final products. And that's true for all of the atoms that would be present. All that we're doing is changing the connections between them. If you want to think of this as being like a ball and stick model in class, you get the balls out, fine, you can change the springs connecting them, but you must use all of the balls sitting on the table at the end of the reaction.